Welcome to Napoleon Engineering Services. I'm Chris Napoleon, the President and Chief Engineer. At Napoleon Engineering Services, we specialize in bearing inspection, bearing testing, and custom bearing manufacturing. We employ roughly 50 people, ranging from machinists, engineers, and administrative personnel. What's interesting about a bearing is that it doesn't look like a complicated piece of equipment, but it's highly technical. And what's interesting is that is not the bearing itself, but the application that it's involved with. And it's the application that makes a bearing come to life. We're involved with applications from aerospace to agriculture and everything in between. And that's what's awesome. A bearing brings to life so many things, and to be part of that is interesting. And it starts with getting the right education, getting on the right path. Starts in high school and it continues. You know, we are devoted to training and teaching people about bearing technology. And we want a pipeline of kids to come in here and to have a successful career. But it really starts with your formal education in a variety of curriculums, from engineering to business to sales to management to human resources to accounting to payroll, to the legal aspect. So there's all different avenues of educational paths that can lead you to Napoleon Engineering Services. Well, I've been studying and developing bearings for over 30 years. And it came from my interest in aviation, quite frankly. And I got my start manufacturing and designing bearings locally for an aircraft engine bearing manufacturer. And I also had an entrepreneurial spirit, and I married those two things. My interest in aviation, the newfound knowledge that I got through the training and development I got at my first job, and started my own business. We're in our main office area here for our tour, and this is where we do our design and development of custom bearing manufacturing. So we've got people that were born and raised right here in this local area, and doing the jobs associated with custom bearing manufacturing. For instance, Teresa's our customer service representative for CBM. She's quoting the job, she's taking the orders, she's entering them, and flowing information down to some of our engineers. So we've got Al and Skip and Austin and Eli and Ray. They're part of the design team. They are taking the order that's entered and developing all the prints and specifications to meet the customer expectation. We've got quality department with Ashley. She's ensuring that we are flowing down the requirements that the customer places on us and that we're following them out. So Ashley's from Otto Eldred, went to Penn State, and now working with us. What you'll find a lot around here is that most of the people, the majority of the people, 95% of the people, were all born and raised within an hour of here, educated locally and work here. We know we can be successful with the people that were born and raised right here in around only in New York. So as we come out into the shop floor, one of the first things you're going to notice is that we have white floors, bright lights, and we're highlighting the NASA astronauts that are flying on the spacecraft that we have bearings in. Our bearings are in all of the engines for SpaceX and their Falcon 9 rocket. And we just launched Bob Behnken and Doug Hurley into space a couple months ago for the first commercial crew mission in US history. We're very proud of that. And it's important for all of the employees here to understand that they are responsible for Mike Hopkins and all the astronauts. They're responsible to deliver them to space and back. That's a huge responsibility. and it's a mature responsibility. And that's why we need young people like you that can take hold of the mission that we do and engage in it and take responsibility. And we're looking for mature people that get on the right education path. And then when you come here with that passion, we'll take you the rest of the way. We will teach you how to do what we do here. So let's take a look at what we do. We're entering our hard turning, soft turning, and milling cell. Alex here is an Allegany limestone graduate, went to Alfred State. We have over 33% of our workforce was educated at Alfred State in either machine tool technology or engineering. Alex runs one of our high-end CNC lathes. He does all the program for it. We have a lot of responsibility that we place on our machinists to do this job. So what are you making today?
FTT inner ring.
Okay, so this job that Alex is working on, he's making inner rings. And this is interesting. These are bearings that are going to go into a jet-powered engine for a drone. So our military, which allows us to live the lifestyle that we live every day. We go around using the internet, using our cell phones, and we have a great life. In order for that to happen, it's because of men like Alex and the men and women here at Napoleon Engineering Services that provide product that works in really tough applications that protect us. So, like Alex, Josh also went to Allegany Limestone School, went on to Alfred State, and is now our lead machinist in the milling area. Today, Josh is milling some tooling, and from the engineering department, we send out prints that show him what he needs to do, and also a router to route the part through the manufacturing process. What I want to get across to you here is that this is a means of communication. So we have all different ways of communicating. When we talk about communicating, you usually think about people that just speak by word of mouth. But that's very difficult to say, hey, Josh, take this piece of bar stock and machine it into something. I want to hold this big and I want it placed right there and right there and right there. That's difficult communication. So we use in manufacturing different methods of communication, our prints and our routers to flow that down. And it's very important that you have the skills and develop the skills to do that effectively so that when he makes the part, it meets our expectation. Okay? So one other thing that I want to stress, and I stress to all my tours, is the importance of attention to detail. Okay? And attention to detail is critical in every aspect of life. Whether you're baking a cake or making a bearing, going for an interview, you have to have attention to detail. It's what keeps these astronauts alive, and it's what keeps airplanes in the air. And when we fail in our attention to detail, we fail our customer and we fail our product from being able to do what it's intended to do. So those drawings come out from engineering and they say, take this and turn it into something. So that's what Dan's doing here. Dan's another Alfred State graduate, born and raised locally. Dan, you went to school in Cuba or Hinsdale? Hinsdale graduate, Alfred State graduate, working here. So again, local people impacting our local community and doing great things. So we have this raw material that we're going to soft turn into an inner ring. From this to this. Okay? After here, the bearing leaves the plant and goes out for heat treatment. We heat treat the part to make it very durable, very hard and robust and resistant resistant to fatigue. Once it comes back from heat treatment, it goes to our grinding line, which we'll go to next. So after the ring comes back from heat treatment, we call it a black ring. And you can see these inner rings, they're smaller than the ones that I just showed you, but they're dark in color. They've gone through the heat treat process. They're very hard, they're very durable. And so the machining process is very different at this point. It goes through a lot of grinding operations. Joe, another Alfred State graduate, is doing the first operation, which is to lap or to grind the faces flat and then parallel. That way it's ready for the next operation of outside diameter grinding, inside diameter grinding, and then raceway grinding. This is a booklet for, or our router and print book for a particular job, SOI Aviation. Inside here is a lot of documentation with our routers, our drawings, and all of our inspection records, which are later in the booklet. This travels with the parts, and this is just for one ring in the full bearing. We've got an inner ring, an outer ring, a cage, and the rolling element that all come together. So there'll be 4 books that make up one bearing, and this paperwork is just as important to be done correctly as the part itself. So I'm here with Nick, and he's doing OD grinding, or outside diameter of this small inner ring for a ball bearing that's used in an aircraft engine application. So he's programming the CNC grinding machine. I'm here with Craig Cobb. Craig is our grind line supervisor. So Craig manages the whole grinding line and the people. He's a specialist in machine setup and the programming. He's making sure things are running smoothly. Craig's working today on a main shaft bearing for a GE engine. So this is a double row angular contact ball bearing. It's probably one of the most high precision bearings that we're going to make, with a huge reliability associated with it. So when we manufacture a bearing, it's one thing to have good drawings and good communication and good flow down, great machines and great machinists, but we have to test the bearing to make sure that the integrity through the manufacturing process has not been compromised. And we do that through a variety of ways, and one way is through non-destructive testing. So I'm in front of one of our non-destructive testing pieces of equipment called magnetic particle testing. Kind of like when you go to the hospital and you hurt your knee and you get an MRI. They don't automatically cut you open and look in and say, hey, I now know what's wrong with your knee. They use non-destructive techniques. So Chris, come on in here. So Chris is one of our mag particle inspectors. Yep. So we were just looking at that part that Craig was grinding. And what we're going to do with mag particle testing is induce a magnetic field within this part, and to determine if there's any surface cracking or subsurface cracking. So we have a fluorescent media. This is a carrier oil mixed with very fine magnetic particles. And when we induce a current, and for any magnet, there's a north and south field. And if we have a crack in the part, we have a break in the current. We have a break in the magnetic field. We have a new north and south pole, and the particle is attracted to that point. So it's a way for us to determine surface and subsurface cracks without physically destroying it. We will 100% inspect every ring. Okay, just final to the honing process. And we're going to do the exact same thing in our surface temper lab, which we'll go to next. When you burn a bearing by putting too much heat into the part, it changes the hardness of the steel. And we just talked about how we heat treat a part to make it very hard. And if we diminish the hardness through excessive grinding, where we put too much heat into the part, we can soften the steel first, and then it's not durable. Or if we continue to put too much heat in, it becomes brittle. And that's not good, because then it's going to crack under load. So we want to maintain the perfect microstructural balance for hardness and durability, okay, or toughness we call it. And in the machining, we can compromise that. And this whole line enables us to determine if we put too much heat in. So when you burn something, you know, if you ever taken a piece of steel, or you have nails in a bonfire and you look at it and it's all dark because it got hot. But you don't, for our material, it doesn't take a lot of heat for the top layer to change the microstructure and the properties. So what we're trying to do here is to etch the surface, to bring out the grain so that we can actually see if it has changed the hardness level by tempering, which is to draw back the hardness, or to reharden, which is to make it brittle. So what Chris is doing right now is cleaning the part. If we don't clean all the oils and contaminants that are on the part, then we're not going to get the right etch. We might have stains and a visual appearance that compromises our ability to do a visual inspection on it. Then we're going to rinse. So we have a cleaning, a water rinse, now he's visually looking at it to see if it's called a water break test. This is to make sure that if there's still a film of oil, the water is going to run off in a different way. It's going to, as opposed to the water break test, it makes sure that all the water is all over the part, right? If it comes off the part, it still means that there's oil on it. We're going into a ferric chloride etch, and you're going to see when the part comes out, it's much darker. He does a real good water rinse, followed by a neutralizer. We had it in acid, so we want to neutralize it so that even though he's rinsed it off, he doesn't want any of that acid that could be remaining in pores to continue to eat away at it. We just went through an audit for our NADCAP certification. It's an outside source that comes in and reviews how we process parts in this chemical etching process. And if you follow all the rules, they will certify you to be a supplier of this process for the aerospace and defense industry. This came out of the isopropyl alcohol, which is drying off the water, and now he's going to his oil or rust preservative tank. And now it's ready for inspection. This is where the rubber meets the road, actually. This is all that process is for us to now use our eyes and our knowledge of to evaluate the quality of that part. So we talk about attention to detail, and when we follow this process, there are timers for every tank. There's a program for each material, and there's a time for each material that it has to be in there. This light box that Chris is working in, we have to measure on a regular basis the number of foot candles of white light, and if it's insufficient, then we have to change the bulbs. So he's done his visual inspection. It's a known, he's found a known defect. He's pointing to it. It's a slight dark mark that is telling us that there was too much heat put into that part at that point. It's changed the microstructure and it's now softer, so that's a rejected part. This is where all the parts come together. And it's an opportunity to really take a look and say, what is a bearing and what does it do? So here is a typical ball bearing, all right? We have an inner ring, an outer ring. The brass piece is the cage. It cages the ball. We sometimes call it a separator. It separates the balls. Or we call it a retainer. It retains the ball. And then, of course, the rolling element itself. In this case, it's the ball. And when all of these working together as a team, it allows for rotation with very low friction in the presence of lubricant, as I said before, or oil. So the process for a bearing like this is to take the inner ring, cage, and the rolling elements and bring it to an induction heating area where we heat up the outer ring so it expands, and then the inner ring and the balls and the cage fall in. And when it cools, it's one unit. After the bearing is assembled, it goes through a marking process. So this is one of our laser marking machines. So the information that's to be marked on the inner and outer ring are loaded into the program. The part's placed within the laser marker, and the shield comes down, and it puts a controlled heat into the surface that's localized to produce a difference in the color, producing the mark. After we assemble, mark, we come into our clean room and do our finish cleaning and preservation. So these are rings. This particular bearing is for SpaceX. It's the turbo pump bearing for their new Raptor engine. And it's still in the component stage because this particular bearing is intentionally made as a separable bearing. So the final process, final inspection, washing, and packaging is all done in this clean room. So we're in our inspection and testing area where our engineers and management team reside. And again, our inspection and testing department is considered the largest independent inspection testing facility in North America. And what this group does is we listen to the customer as to what their problem is and how are we going to solve their problem of qualification of different suppliers, or to evaluate seal designs, oil lubrication quality, you name it, through one of our inspection or testing pieces of equipment or capabilities. And that's really what Tom's role is. Tom is our test engineer, and so he listens to the customer, and he knows that all the capability that we have out there in our test lab and inspection lab. And he says, oh, a la carte, I'm going to pull this off the shelf and package it together to produce a solution that is cost effective and is cost effective to provide technical information so our customer can make an informed decision. So there is the misconception that a lot of engineers just sit in front of a computer all day and they never get up from behind the desk. But as you can see, some of the fellows up here that I described are not at their desks. They are out on the shop floor taking care of the business, taking care of the test rig or the equipment that they've designed. We're now in our metallurgical lab, and I kind of look at this as our what is it, NCIS? Is that the name of the television show? You know, who hasn't watched one of those TV shows? And they're trying to figure out figure out a murder or just solve a problem. And it's really through technology, and that's what we do in here. So we get failures from equipment that are sent here that have bearings that maybe didn't work that well. They're not necessarily they're not ours, but here's a bearing that was a bearing at some point in time in a piece of John Deere equipment, and it failed, and they want to know why it failed. So they've sent us some components from a variety of different number of hours in service for us to determine why that happened, because they also don't want it to happen. Could be a warranty claim, and their motto is nothing runs like a Deere. In the metallurgical lab, we also do visual inspection because we use high-end video microscopes to evaluate the quality of the product. Our eyes are a very powerful tool, and we have equipment to measure and to test things, but we have to look at the product at the end of the day. So it comes in here for a final visual inspection of all the areas of the raceway under magnification to evaluate its overall quality of workmanship. One thing we do in the Met Lab is to evaluate the microstructure of the steel. So we will do destructive testing. After a part comes back from heat treat, we take some samples and we bring it in here and we physically destroy it. We cut it, we mount it, we put it into a mold such as this so that we can look at the microstructure of the internal body of the steel. And we're trying to make sure that we don't have non-metallic inclusions, that the grain structure is uniform, that we don't have too much carbide banding. This is like the blood test when you go to the hospital and you do a blood test. You actually know what your cholesterol level is and so on and so forth. So that's what we're doing here. And then we rate it. We look at ASTM standards to rate the steel and to determine if it's going to meet the application requirements. So we're in our contract inspection area where we specialize in what we call source qualification inspection. The source qualification inspection is intended to evaluate a global supplier. So Cody has some product where's this made in? What country? Do you know offhand?
I'm not sure.
Let's see if it's on the part itself. C&U. So that's made in China, and our customer has asked us to evaluate the quality of this particular supplier out of China. So the product comes in, it starts in the assembled condition, and we drill down, measuring every possible characteristic to evaluate the design intention of that manufacturer, how well the manufacturing plant carries out the design intention, and the overall quality of workmanship. That's our goal. Evaluate the design, manufacturing capability, and overall quality of workmanship. And we do that through a variety of inspections and test procedures that are done here in this room. What's interesting to me is that we do this work for all different original equipment manufacturers who really have a passion to make their finished piece of equipment the very best that it can be. One of our customers is Lazy Boy, and I could highlight any number of customers, but think about a manufacturer who makes lounge equipment, chairs and couches and recliners, and they are so passionate about making a good product for us as the consumer that they're willing to pay money to evaluate their suppliers, and specifically the bearing supplier. So when you're rolling back and forth in your recliner, that it does so for as long as you want and for as quiet as you'd like it to be. It's pretty impressive. And we're here to provide them with technical information so that they can make informed decisions about the product that they intend to purchase. One of our standard bearing test rigs. This is a rig where we'll have 4 bearings on a shaft, and we're applying a rotational load to the bearing through this electric motor, along with an axial and radial load to the bearings, and we'll run until one in that set fails. And we repeat that 4 times. So we'll try to get a certain number of failures and a certain number of suspensions, and this allows us to evaluate the difference between one supplier and another if we're testing bearings. It also allows us to evaluate the lubrication if the lubricant is what we're trying to determine if it has a difference in the or an impact on the life between one lubricant manufacturer and another. So these rigs provide us with a lot of different capability to provide technical information so that our customers can make informed decisions. But I think what's really interesting to me is that we didn't buy these rigs. We designed them. We started with a clean sheet of paper and designed them, built them, assembled, fabricated, in order for us to get the test results. And that's all done with people that were born and raised here in our backyard, who got on an education path and came here, learned the specifics of design and machining and engineering and bearing testing, and enables us to provide, again, technical information so that our customers can make informed decisions. And that's probably something I'm most proud of. And I think a lot of people, and kids included, think that all we want are engineers, machinists, welders, assembly people. And that's not true at all. We need people from all walks of life. We need people that have accounting skills, marketing, production control, human resources, a variety of skills. We need legal support. And so a manufacturing operation has a lot of skill sets that are required to make the product and to be successful as a business. So behind me is an example of marketing material. When we go to shows, we have to present ourselves. And people have to have, if you like photography, if you like graphic artwork, you can have a career in the manufacturing world, because we need that to sell our product. Well, that concludes our tour of Napoleon Engineering Services. It's been my pleasure to have you on board today to give you a snapshot image of a day in the life of the people here and what we do and how we have an impact on the entire world relative to bearings. And I challenge you to go beyond just this video and go beyond the other videos that you might see, to call, email, take real visits, and talk to people about the careers that they are involved in and the skills that they have, because we're passionate about them. And you are the future of our organizations. We need you to get on a path, an education path, and develop the skills and be passionate about that. Because Dream It, Do It is all about developing a talent pipeline for those that want to be involved in the advanced manufacturing world, like here at Napoleon Engineering Services. So I'm always a resource, and I appreciate your time today, and good luck in your future.